This is an organic teacher assessed task. Level it's pitched at is IBHL. So question 1A, consider the two-stage reaction pathway. So you've got your initial molecule, you've got your target molecule, and it's going through stage 1 and stage 2. So there are two processes involved. The bit that you're actually familiar with is the chlorine, and you can see that the chlorine's being removed and it's being replaced by a carboxylic acid. Now if you think about your reaction pathways, you don't know any reaction pathway that would directly convert a halogenoalkane into a carboxylic acid. The rest of the molecule looks terrifying, but it's not actually relevant in the question that we are looking at. So think about, what do you know? So to form a carboxylic acid, what reactions do you know where carboxylic acids are formed? The only one that we have studied is when you take an alcohol and you convert it through aldehyde into a carboxylic acid. So this precursor here could theoretically be an aldehyde, or it could be an alcohol. Then you need to think about, if it was an aldehyde, what would you have had to have had before that? So you would have had to have had an alcohol, and before that you could have then started with a halogenoalkane. So the fact that it's a two-step mechanism implies that this is converted into an alcohol, and the alcohol is then directly converted into a carboxylic acid. So X therefore must be an alcohol. The chlorines are removed and substituted by an OH group. So the rest of the molecule remains the same. The rest of the molecule is insignificant. What is significant is that the Cl's are replaced by OHs, and that's all. So copy the molecule, but have OHs at the end instead of Cl's. Also notice that this is H, then O, then CH2, not O, then H. O, then H implies that potentially this could be a different functional group. So this means hydrogen attached to oxygen attached to carbon. So do ensure that you've got your organisation the right way around. The next question is simply knowledge. State the reagents and conditions for the second stage of the pathway. If you don't know what this second stage of the pathway is involving, that makes this question quite difficult. So the second stage, going from an alcohol to a carboxylic acid, is an oxidation. So the reaction is going to need reagents that are acidified dichromate. Acidified, so your H plus ions, and your dichromate ion, your Cr2O72-, or you could indicate that it's potassium dichromate, or you could even use sodium dichromate, but those would be the actual chemicals that you would need to add. And the conditions are reflux. So if you had distill only, you wouldn't form a carboxylic acid here, you would just form an aldehyde. So you have to ensure that you put reflux. Heat is acceptable, but reflux is the most important part of that question. Again, just to repeat, that is just knowledge. The next question, chlorethene is an important organic compound used in the manufacture of a polymer. Draw the Lewis structure and predict the bond angle. So this is bringing a separate part of the course into the organic area. It's still organic, but it's looking at it from a different angle. So you've got chloroethene, therefore you've got your double bond. Draw out your structure for your ethene, which is your monomer that you're beginning with. Then what you need to consider is how many bonding regions you have. So you've got 3 bonding regions, one here, and one here. Yes, you have got a double bond, so yes, you have got 4 bonds, but you've only got 3 bonding regions because the double bond is locked into position. Those 2 bonds can't separate from each other. Therefore, you have got a 120-degree bond angle. If you ask for a shape, it would be trigonal planar. The bond angle accepted could be slightly less than 120. Because we've got a double bond here, we have a high area of electron density, and therefore the repulsion that would happen from this region would be slightly more than if this was a single bond, if you imagine something like BF3. So you could have extra repulsion, which would force this in a little and force this in a little, and might give you a bond angle of around about 119, 118.5. Something slightly less than 120 would be the best answer to go with, but 120 or slightly under 120 is acceptable from IB. This is a Lewis structure, so you can accept any structure that's got your lines involved or dots and crosses, so all of those would be acceptable. Realistically, for the Lewis structure, we should probably have put in the extra electrons here for the chlorine also. The electrons for the hydrogens and the carbons are all involved in the bonds, but the chlorine will have some lone electrons on there, so best to get those in. Next question, draw a section of the polychloroethene containing 6 carbon atoms. So if we're starting with ethene, then we've started with 2 carbon atoms. This is 6 carbon atoms, so it's going to be 3 lots of ethene, 3 lots of the unit. So unit 1, unit 2 and unit 3. They are connected together because they've joined together as the double bond has broken open. Make sure that your chlorines are in the right place. So some students will put a chlorine here and then a chlorine here, and that's obviously not correct, because as the molecule opens up, you should effectively have whatever you begin with repeated 3 times over. You've got your round brackets, you've got your letter N to imply that this is a long unit, a lot of units that are together, and it could be any number of units. And what is important is that your end bonds, to imply the fact that these could be connected to even more substances, need to be long and overlap outside of the bracket. So this, for example, would not be acceptable. This part here is what's acceptable. The next question is SMSC, so social, moral, cultural, economics, health, political, those types of questions do come up. Outline why the polymerization of alkenes is of economic importance and why disposal is a problem. So it's cheap, plastic's cheap, versatile, it's got many uses. It's non-biodegradable, which means that it ends up in landfill or it ends up being burnt, which causes carbon dioxide pollution. Try to be specific in any pollutants that you are referring to in any questions at all for IG, IB or A level. You could also have that they don't decompose quickly. Litter, yes, it is true, but here we're at IB, not IG, so litter wouldn't be enough to get you a mark. Next question is a little bit sneaky. You have to make sure you read it properly. Chloroethene can be converted into ethanol in 2 steps. Deduce, so figure out an overall equation. So what I would do is I would think, right, this is what I'm starting with, so this is my initial precursor. This is what I'm ending up with, so this is my target molecule, and I need to figure out how to get from here to here. It tells me that it's 2 steps, so this is step 1 and this is step 2, and I have some sort of intermediate molecule. So then think, how can this happen? First thing that has to happen is I have to turn this into an alkane, halogenoalkane, so the double bond has to open up, and then once the double bond's opened up, I need to replace my chlorine with an OH. So I'm going to have to substitute my chlorine for my OH. So that would be my thinking on this question. So from there, I would then go, okay, for the first stage, I'm going to need to add hydrogen. That would be hydrogenation. So adding hydrogen, and also as an aside, remember that you would need a nickel catalyst. So as you can see highlighted there, it is green, but it looks yellow. I've got my initial precursor molecule, CH2CHCl, adding hydrogen to give me CH3CH2Cl. So it's still got the halogen attached, but now it's got extra hydrogens, that double bond has been removed. The second stage would then be nucleophilic substitution. So you have a nucleophile, OH, substitution because the Cl is being replaced by an OH. So you take your intermediate molecule, your CH3CH2Cl, you add OH minus, which is your nucleophile, and you end up with your alcohol. Don't forget that you need to include your Cl minus ion, which is released as the OH minus is attached. So it is a substitution, it is a replacement. So you have to make sure that the Cl minus is shown as being released in your equation. And also it doesn't matter whether you put OH minus or NaOH. So NaOH is a substance that you're actually going to use, but it's only the OH minus that gets involved in the reaction. So if you have NaOH here, you'd end up with NaCl here. Both of those are acceptable, but it's best to stick to one format so it's not to confuse yourself. The next question, state the reagents and conditions necessary to prepare ethanoic acid from ethanol in the laboratory. This is basically the same or similar to the first question, looking at the carboxylic acid being formed. So what would I think here? I'd think, okay, I've got a carboxylic acid being formed, it's coming from an alcohol. If I've got a carboxylic acid from an alcohol, then I've got oxidation. If I've got it going all the way from an alcohol to a carboxylic acid, that's 2 stages of oxidation, because I go from an alcohol to an aldehyde to a carboxylic acid. So 2 rounds of oxidation. I'd need to tell you what the oxidizing agent is, O in square brackets, which is K2Cr2O7, that's your dichromate ion, acidified dichromate. So here you could also have conc H2SO4, so this is just a different way of writing it. And the fact that there are 2 rounds of oxidation means that you have to state the conditions as being reflux, because if you didn't have reflux, if you distilled immediately instead, then you wouldn't end up with your carboxylic acid, you'd just end up with your aldehyde. Most of that is knowledge, a little bit of application if you're going through several stages.